Hi, third graders. This is Miss Warner. I'm so excited that we get to do science together today. Also, I cannot believe it's already May, which is crazy, but I'm so excited. The year is almost wrapping up, and you guys are almost fourth graders, which is so exciting. Today, we're going to do a science lesson and a few experiments together, so I'm really looking forward to doing that with you guys together. Um, just a few symbols. We've looked at these the last few weeks, so I'm going to go quickly. But if you see this gray pause symbol, make sure that you pause the video so you're stopping and thinking. We'll see this pencil a few times. That means I want you to write. So we'll be doing a couple experiments, and I want you to predict with that. If you see this guy, waving brain guy, you can stop and think. And then if you see the blue comment, symbol, make sure that you post your thinking in the comments so that I can look at them and respond to you later. So today you just need a piece of paper and a pencil. I'll be asking you to stop and predict along the way, and then just to kind of think about the learning overall. So you'll want to have a piece of paper and a pencil with you. So our objective today, and I'm really excited for this lesson, is that you can identify how heating and cooling change matter. So we're thinking about if we have an object, what's going to happen to it if we heat it, and what will happen if we cool it. And we'll talk about that together today. So the first thing that I want to do is just a quick review. We studied the states of matter before, but I want us to look at that again. So the first state of matter is a solid. And so solids have a definite shape and a definite size. So for example, if you have a skateboard, you know the shape of a skateboard, it's not going to change unless something happens to it, but it's not going to change. And it has a definite size. So we know how big the skateboard is. Another example is like glasses, right? This is a solid. We know the shape of my glasses is not going to change, and we know the size. So some examples are a skateboard, like I said, and then also a chair. But there's obviously plenty more solids out there. And then if we're thinking about a liquid, so that'd be another state of matter. Liquid has a definite volume, so we know how much of a liquid there is. And also a liquid takes the shape of its container. So for example, if you have a can of soda, I just chose Diet Dr. Pepper. We know that the liquid inside, so that Dr. Pepper, is taking the shape of its container. So it's filling the shape of that. Another example is like a water bottle. The water in my water bottle right now is taking the shape of the container. And then a third state of matter is gas. So gas has no definite shape and no definite volume. It takes the shape of its container. So an example of this is like a balloon. The gas inside the balloon is taking the shape of the balloon. It's filling that space, but it has no definite volume or shape. And another example is like the steam that's coming off of a bowl of soup. So those are the three states of matter. We're going to do a little, We're going to do a little science experiment, which I'm so excited about. We're going to microwave a marshmallow, and we're going to see what happens to the marshmallow. So I want you to think about, if we put a marshmallow in the microwave, what do you think might happen to that marshmallow? So I want you to make a prediction here. So what do you think will happen when we microwave a marshmallow? So we're putting those in the microwave. I want you to answer this in the comment section. So pause me, think about your prediction, and then leave it for us in the comments. So you can say, I think that blah, 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 blah. Tell us what you think is going to happen. Pause me here, make your prediction, and then you can come back to the video and see what you think is going to happen and see what actually happens. All right, so you're currently sitting in my microwave right now, but in a second, I'm about to put this marshmallow in the microwave and we're going to see what happens to it. So right now, this is what it looks like. It's a solid right now. I want you to think about what you think might happen. So think about the texture, think about the size of it, think about the color. I want you to pause the video here, make a prediction in the comments. What do you think is going to happen to this marshmallow? All right, I'm putting this in here. I'm taking you out of the microwave so you don't melt. I'm gonna set the timer for just about 15 seconds. So we're gonna wait. We're at about 7 seconds now. Ooh, I see something happening. All right. Look what happened to our marshmallow. All right, so it looks like it fell over, but here's our marshmallow. Here was our original marshmallow. So you can see that this one got a lot bigger. It also changed texture. So this one was solid. This one is super ooey and gooey. So this marshmallow, when we heated it up, it changed texture and it also changed the size of it. All right, so we saw, let me move myself. We saw that the marshmallow did change. So when we put it in the microwave, it changed size. It got bigger, so it like poofed up. It also changed shape. So it used to be more like a cylinder, and now it's really, I don't know how to describe the shape. It like poofed out. It definitely doesn't look the same. And it also changed from a solid to a liquid. So we kind of like melted the marshmallow, and it went from being a solid to a liquid, and you saw that in the video. But I thought that was a really fun experiment to show this. So I want you to look at this picture now. We just saw that a marshmallow changes when you add heat. This is kind of related. I want you to look at this picture. What do you notice and what do you wonder? Think about that for a second. Some things that I notice and wonder is I see, obviously there's like some logs that are on fire. It looks like they might be having a bonfire. So like if you go camping, sometimes you'll make a bonfire. And I see someone back here with like a stick. It almost looks like they're about to roast something. So maybe they're about to roast a marshmallow. I'm not sure. I also see, it looks like they're at the beach to me because I see some sand. But what I really want us to focus on is these logs that are burning. I want you to think, how does fire change the wood? So we had some wooden logs, and they're now on fire. How do you think the fire is changing the wood? Pause me here in about 5 seconds. 5, 4, 3, 2, 1. I think that the wood is going to change color, right? The wood is brown, but if you light it on fire, it's going to get charred, so it'll get very black. I think like the wood is changing shape, so when you burn something, the shape of it's changing. Those are the first two things that pop in my mind, but there's a lot of other changes that are happening here as well to the wood. So that fire is changing the wood. All right, another thing to think about, heat changing an object. This is a picture of Mrs. James and Miss Warner last summer at La Michoacana. We got popsicles. It was very yummy. We love going there. I want you to think for a second. What do you think will happen to our popsicles if we take them outside or we go in the sun? So Memphis is very, very warm. What do you think is going to happen to our popsicles if we take them outside? Now, I'm sure a lot of you have done this before, so think back maybe. What do you think will happen to the popsicles if we go outside? So if we go outside, our popsicles are going to melt. So if you go out in the hot sun and you have a popsicle, that popsicle starts to melt. So when we add heat to something, that can cause melting, and so for example, a popsicle. We also saw that with our marshmallow, right? We added heat to it, it started to melt. And it can cause evaporation. So if you add heat, another example, I think this is like a cup of hot chocolate. That sounds really yummy as well. When you add heat, so this hot chocolate's very hot, it starts to steam. And so the steam from that hot chocolate is evaporating into the air. And so adding heat can cause melting and evaporation. Excuse me. In the comments below, I want you to leave an example for me. So you'll have to pause me after this. Leave an example of how heat can cause something to melt or evaporate. Don't use popsicle or hot chocolate, but give me an example of either something melting or evaporating. Leave a comment down below with your name and your example. All right, so we're gonna do another experiment together, and I'm so excited for this one. I want you to think, do you think that water can be a solid, a liquid, and a gas? I want you to think about what your evidence might be for this. So, do you think water can be a solid, liquid, and a gas? And what's your evidence? I want you to leave that in the comments. So, you're going to need, getting ahead of myself, you're going to need to pause me here. I want you to write this down and then leave it in the comments. Do you think that water can be a solid, liquid, and a gas? Pause me here, and then you'll get to see my experiment where we will see if this is true or not. All right, so I just took this ice cube out of the freezer. It's nice and cold. So right now, this ice is in the solid state. So we're going to put it in a pan on the stove, and we're going to see what happens. So I want you to think for a second. If I put a solid ice cube in a pan over heat, what do you think is going to happen to the ice cube? Go ahead and comment below what you think. All right, here's our ice cube, and now you can see that this ice cube is slowly melting. So the heat underneath the pan is changing this ice cube from a solid to a liquid. So we have solid and liquid now. We need to think, what do you think is going to happen next? Do you think that we can change this water into a gas? All right, so now it's a little steamy, but now that we have our ice cube in there and it's melted and boiling, the water is now going to start evaporating. So if you remember from when we studied the water cycle, the steam or the water is evaporating. And if you look closely, you'll see that there's not very much water left in the pan because it's all evaporated into the air. So we just turned an ice cube into a liquid and then the liquid water into a gas. All right, so you should have paused me, and now we're back here, and we saw that water can be a solid, a liquid, and a gas. And so this picture is not exactly our experiment, but I thought it was really interesting to look at. So we started off with an ice cube, and we know that ice is a solid because it has a definite shape and a definite size. We put that ice cube in a pot and we heated it up. And that ice cube quickly turned into water. So it became a liquid. So we went from a solid to a liquid. And then what happened is we saw that the water was getting really, really hot. It started to boil. And eventually it turned into steam. And so we saw by the end of that experiment, there was barely any water left in our pot. So we saw that steam, that water was steam in. Yeah, water became a gas, and that was the steam from our pot. So, and I thought this picture was really interesting. I hadn't thought about this. This is like an iron. So sometimes you'll iron your clothes if you want to get wrinkles out of them. And so sometimes irons have water in them, and you put it in the iron as water. But once it gets really hot and it comes out as steam. So it actually goes from a liquid, you add the heat, and it becomes a gas as steam. So here's just a few, I don't know where to put myself. I'll put myself up here. Here's a few examples of changes in texture. And so these are just 3 examples that I chose, 3 foods that I thought were fun. I chose a gummy bear, I chose popcorn, and I chose a marshmallow. So first example is a gummy bear. So you'll notice this gummy bear, I think it got heated up. And so it looks a little melty. The heat caused this gummy bear to melt and become a new shape. And so when you heated up that gummy bear, it went from a solid to a liquid, similar to our marshmallow, and it became a new shape. So it went from being this cute gummy bear, now it's all liquidy, right? It doesn't have as cute of a shape anymore. So the heat changed the shape of that gummy bear. The next example is popcorn. And so popcorn, after you heat it up, can change shape, size, and color. So it went from being a kernel, you add heat and it became popcorn, right? Now you can eat it. It changed the shape of it. It also changed the size. So these kernels are pretty tiny. Once you add heat to it and you pop it, it became these bigger pieces of popcorn. So they grew in size. and it changed color. So it went from being yellow or like a light brown to being white. So the heat changed all three of those things. And then the last example is of a marshmallow. And excuse me, this marshmallow, once it got heated up, now this is a little different than the one we did. We put ours in the microwave. This to me looks like somebody put it on a stick, maybe over that fire we saw earlier. And so this marshmallow changes shape, right? It used to look like ours did before we heated it up, smaller and more like a cylinder. It's now bigger and it doesn't have as much of a shape to it, right? It doesn't look as neat as the other one did. The color changed, so it went from being white to now it looks black and charred. And the texture of it, our marshmallow before was pretty smooth. This one now is pretty bumpy, so the texture of the marshmallow changed as well. And it went from being a solid to being more liquidy, so it's like ooey gooey on the inside. All right, so we've seen for a while now how heat can change an object. So I want you to think, in what ways can heat change an object? I want you to pause me here and think about this. You can just write it down, like spend like 30 seconds writing, nothing crazy. What ways can heat change an object? Go ahead, pause me and come back when you're done. All right, so the opposite then of heating is cooling. And so if heating is adding heat to an object, cooling is taking away heat from an object. So some examples I thought of was like a fridge. When you put food in the fridge or the freezer, you're taking heat away from the object, you're cooling it down. And then another example is like a fan. So on a really hot day, you might turn a fan on in your house to take away some of that heat. So I want you to think, what change occurs when a liquid is frozen? So if I want to put this glass of water in my freezer, what change do you think is going to happen? It's going to go from a liquid to what? Think in your head. The liquid then is going to turn into a solid. So this is like almost the reverse of our experiment. But if I have a glass full of water and I put that in the freezer, it's going to turn into ice. So it's going to freeze and it'll now have a definite shape. So if I poured this glass of water out right now before I froze it, it wouldn't have a shape. It would go all over the place. But if I froze it and then I took the ice out, that has a shape. So it changes. I got ahead of myself. But yeah, so the freezing it gives it a definite shape. So you can put it in like an ice cube tray. And it changes its texture. So if you were to touch water, that would feel different than an ice cube would. All right, so I want you to think for a second. I know I gave you a brief rundown of cooling. I want you to leave me in the comments one similarity and one difference between heating and cooling objects. So you can use evidence to support your reasoning here. Now, you're not just going to say, like, I want you to use a full sentence explaining your thinking. So you have some sentence stems here. One similarity between heating and cooling is, and one difference between heating and cooling is. So leave me 2 sentences explaining your thinking there in the comments. So pause me, do that, and then you can come on back. All right, well, I had so much fun doing science with you guys today. Thank you for watching and watching all the way till the end. That is so impressive. It's really important that you're watching all the way through, so I'm really proud of you for doing that. If you made it this far into the video, I want you to leave a comment telling me your favorite flavor of ice cream so I can respond and learn a little bit more about your favorite ice cream flavors. My favorite flavor is either cookie dough or mint chocolate chips. So curious to hear what your guys' is. But that's all that I have for science today. Thank you so much for watching, and I'm looking forward to learning with you guys again soon. I hope you have a great week. Happy May. And yeah, I can't wait to respond to you in the comments. Bye.